Shit.
Thank you. So for the last couple of Unites, I've been showing you different demos, all surrounding our new data-oriented design technology stack. And we've built a solid foundation for writing high-performance code in Unity. And now we're beginning to build higher-level features on top of it. And we're doing that with real-world production needs to ensure that everything works and performs well out of the box. So what did we want to achieve this time around? We wanted to stream large amounts of content at a solid 60 frames per second. We wanted to go completely nuts with the amount of unique things we can have on screen at the same time. And we had to make sure that we have efficient tools to actually create a large world with a tiny art team of just 2 artists in a couple of weeks. So before we get into the details, let's have Martin have a play.
So hi. So the world we're about to dive into is inspired by the walled city of Kowloon. We've added a bunch of sci-fi elements to it, but let's dive in there.
So look at all those cars. There are 5,000 separate AI agents, all flying on these traffic lanes, avoiding each other and the player. And the entity component system is uniquely suited for streaming huge amounts of scene elements. Each building that you see here is made out of 30 to 200,000 separate entities. And all of that is streaming and then activating all in one frame while still having a 60 frames per second. And then, for good measure, we put in 100,000 audio sources. Each neon sign, every vent, every flying car has an audio source on it, and that creates that dynamic audioscape. So we built this project. Oh, yeah. Yeah, it's pretty cool. So we built this project on our in-preview data-oriented design technology and a bunch of optimizations that we did to Unity to make this come together that we're bringing into Unity 2019.1. So we have the C# job system. With that, we can run all of this code on multiple cores, and we can do that easily, and we can do it safely. We have the entity component system, making it easy to lay out all your data for the best memory access performance. And the burst compiler gives incredible speedups by generating efficient machine code for the target platform specifically for C# jobs. And then we also integrated the entity component system with the HDRP and LWRP render pipelines. And we built a scalable renderer for entities. So Martin, how many renderers did you actually end up putting into that scene?
Well, me and Janus just kept piling stuff in there, right? But I think at the end we're around 4.5 million mesh renderers.
Just a couple. Just a couple. Here and there. Sprinkle them around. So what we did is we have a culling system that is written in C# using Burst, and we perform hierarchical culling and hierarchical LODs. So when a building is outside the view, there's no reason why we should cull those 200,000 separate renderers. We can just reject them very, very, very quickly. And then we did some intense optimization work on our rendering inner loops to make sure that everything is performing beautifully. So this level of performance and scalability allows us to completely change how we author content. And it also means that we can load and edit these scenes really efficiently in the editor. So Martin, show us a little bit about how you actually assemble this content.
Yeah, so when a few months ago, which is actually when we started building this, our environment artist Janus and me were approached with this project, which sounded a bit crazy. So how would we build a streaming world by October? To us, this conjured up images of, massive streaming worlds and huge openscapes. But with very little time, what could we really do in that time space? So let me dive a little bit into how we build it. So I'm going to open up the scene. And the thing you'll notice is that the LOD system that Joe was just mentioning, you're seeing it in action now. So the first thing it loads in is the H-star. So very quickly we're in the scene, and it's streaming in hierarchically stuff as it encounters it down the line. So it doesn't take long to open a world of this scale and size. And once we're in there, the ECS representation of every mesh renderer actually makes this pretty damn interactive. So we're able to fly in edit mode around our city, vehicles spawning on paths, buildings being streamed. So I'm going to head over here, home in on this particular building, which I've practically prepared at the top of my hierarchy. And at this level, we just see a single object, because we're still in ECS representation, but it's a sub-scene, and it's part of the streaming scene setup. And I'll open up that for editing, and we'll see that a whole game object appeared underneath it. So these are nested prefabs, right? The entire building is a single prefab. But I can go in on this level and, move stuff about. Maybe I would want to, tunnel through the building or something like that, or add a bespoke game location. This would be the right layer of inheritance to do that in nested prefabs. Or I could, go deeper into the building itself. And that would allow me to make changes to all buildings of this type. In here, I distribute things like neon lights that are repetitive throughout the scene, but don't repeat that well. So they're good to place on a building level. If I go deeper yet, I can go into a corner tile piece, and this is where the satellite dishes, the air conditioners, the dirty laundry, etc. is distributed. And I can go to a leaf prefab node, which is actually a prefab variant, where I have the air conditioning unit. So this is the level of detail on every prop that you see of the 4.5 million mesh renderers. They are actually fully detailed game assets with every blade modeled, etc. And in here we have our ECS sound emitter source as well. So literally every single air conditioner in the entire level is playing its noise. We actually don't have any ambient sound loops at all. It's just all the noises coming together. So the benefits of nesting prefabs were quite immediate on this. We could easily manage our base assets with the FBX inheritance given by prefab variants, and reduce permutation immensely by having deeply nested hierarchies to form up each city block. So buildings shaped out of tiles, dressed with detailed props. And this made it really easy for us to go and make changes and have them propagate globally. Without this new workflow and the performance provided by ECS, it wouldn't have been possible to maintain this level of detail and polish the city to this amount in a few months. So yeah, With these new features, everyone from audio designers to level designers and artists can easily work in parallel and inject their changes anywhere in the hierarchy they wish without obstructing each other. So yeah, to recap, we have a scene with 4.5 million mesh renderers, 100K individual audio sources, 5K dynamic vehicle agents, and 200K unique individual objects per building, streaming at a hitch-free 60 FPS. So Joe, you're getting something ready?
Yeah, there's one more thing I want to show you. So look at this. So our friends at Nordios and the mobile team at Unity worked together to make this demo actually run on a mobile phone. And a lot of you are making games for mobile. And the entity component system and the burst compiler is a great solution for reducing battery consumption and getting better performance on any hardware. And better performance results in you reaching more users. And that is useful if you're making anywhere from a small 2D game and you just want to reach the lowest end devices, all the way to making a large open world like this. And the good thing is, all of this, including all the assets that we used in this demo, is going to be available in 2019. So thank you.
All right. You know, it just occurred to me, if that runs on mobile, it should run in virtual reality, right? So that's what we're going to do next?
I did model the cockpit of the car, so we're ready.
Yes. OK. You know, it just occurred to me, if that runs on mobile, it should run in virtual reality, right? So that's what we're going to do next?
I did model the cockpit of the car, so we're ready.
Yes. OK.
And whoa, those are the spaceships from Megacity rendering in AR? How many of them do you even have?
3,000, 4,000, 5,000, 6,000, 7,000.
Okay, Brittany, I think we get the idea.
The idea I really want to land here is that the reason why we're able to get so many spaceships working in AR is because we're taking advantage of the data-oriented tech stack, which also allows us to really take advantage of the hardware that we're using.
That's pretty impressive. Over 7,000 unique entities, all rendering in AR at a solid 60 frames a second.
We're going to have the person who started this whole data-oriented tech stack initiative at Unity. We're going to have him take it for a spin. Here we go.
What is your name, and what is your relationship to the founding of Unity?
Well, my name is Joachim. I founded it together with 2 other guys. I knew I wanted to make computer games. I didn't really pay that much attention to high school. That was not what my parents wanted from me, for sure. Back in the day, most game engines were just sort of like a bunch of source code that you had to compile and then you could make a game out of it. There wasn't really that many good options back then. We basically said, okay, we want to eventually ship a game engine, a tool with which you can make computer games. The reason we wanted to do that is because it felt like what we had actually built to make these types of games was actually really flexible and really easy to use. And we just wanted to make something that's really affordable so that, like for people that were like us. We built Unity on that collaboration with those customers. Making a game is hard. It's hard work. I really want to see this transition to making Unity the absolute most performant engine and enabling people to make games that have amazing performance, that look beautiful, but making it easy to do that. The dream version of Unity is that we stick to our values. It's just about being there for our community. That we always listen to what they need and then build exactly that.
Do you think you will work on Unity for the rest of your life?
I think so. I just really love making game engines. I'm having just a blast these days actually just doing that. So I don't see why not.
Thank you. A couple of months ago at Unite, we showed the Megacity demo. And it's been really important for us to stress test the data-oriented tech stack, proving that we can stream, simulate, and render massive amounts of content in a dynamic world. Let's check it out. So today, we're releasing the Megacity project. Let's see what is included. I'm going to go to an editor demo. So I'm just going to open up the Megacity scene here so we can check it out. And in this scene, we have 4.5 million renderers. And they're all getting loaded in the background in the editor. And that's, of course, important because we love great runtime performance. But it's equally important that workflows are efficient when you're working particularly in such big scenes. Check out all of this detail here that we have just hanging around everywhere in the Megacity. And all of these buildings, every single one, is made of around 200,000 separate entities. You can really see how crazy that looks when just flying up these buildings, because that detail is just not on the level of the camera, it's just everywhere. Now, when I click on that building, I can select it, and I can just click on Edit here. And when I do that, I can use the subscene feature to get back to a very familiar object representation. Here we have our game objects. I can move them around. I have my transform component, my lot groups, my mono behavior. I can move them around and change whatever I like. And I can do that in the context of the whole world. And then I can select some of these shacks. And the Megacity, the building block of it, is really these nested prefabs. You can see here, this prefab of these shacks, it is made out of further smaller pieces and different variants put together. And that was really important for us to actually be able to build this kind of scene with this massive amount of content, because we had 2 artists working on it for just a couple of weeks. Now, when I'm done editing, I can just close the scene, I can save it, and what you see then is we are saving the scene to disk, the game objects, but we're also saving the entity optimized representation. And we can actually load and unload the different parts, these different sections. So here you can see the low resolution detail with just a couple of renderers just representing the shell of the building. But then when I load the rest of the scene in, I can do that for streaming, just getting more detail when I'm close up and in the distance you have the shell. But look at how fast that loads. That is the power of a runtime-ready data format. Now, everything that you have just seen, including the content, the game code, and the tools, is available today.